Another popular type of RPC-like system is Java RMI, Java Remote Method Invocations. It's also pioneered by Sun as a form of client-server communication method among address spaces in the Java virtual machine. Java is an object-oriented language where objects interact via method invocations and not via procedure calls. For this reason, this inter-process communication mechanism matches the Java object-oriented semantics as in the form of remote method invocations. Its architecture is similar to what we saw with the remote procedure calls. Client and server processes have client-side stubs and server-side stubs. The server-side stub is referred to as a skeleton. In the Java virtual machines, all of the processes, all clients and all servers are written in the Java programming language. For that reason, the interface definition language for the Java RMIs is also Java. It doesn't make sense to adopt a different interface definition language, like in the case of XDR for RPC, where in this case, everything will be written in Java in the first place. So RMI uses a language-specific interface definition language choice, and in this case, that's Java. The runtime layer is separated into two components, the remote reference layer and the transport layer. This bottom layer implements all of the transport protocol-related functionality. This can be TCP, UDP, shared memory-based communications if the two processes are running on the same machine. Above that is the remote reference layer. This component captures all of the common code that's needed to provide different reference semantics. For instance, it can support unicast, where a client interacts with a single server, like what we had in the previous examples. But RMI can be used for other types of server reference semantics. For instance, with broadcast, the client will contact multiple servers, and then the reference semantics can be such that it will return only once the first response arrives, or only when all of the responses arrive and the responses match. It also makes sense to design other types of reference semantics. These are not the exclusive list. Regardless of the underlying transport protocol, this type of functionality will be implemented in a similar way. So RMI separates it and captures it in a separate component, this remote reference layer. As a developer, you can either just specify the reference semantics you want from the RMI interactions, and the system will take care of the rest. Or if you want something exotic, you can implement just this component and the rest of the system can remain the same. We are mentioning in this lesson Java RMIs just for completeness. We're not going to discuss it in any detail. If you would like to know more, visit the resources that are linked in from the instructor's notes.